It is speculated that all Wikipedia editors suffer from micropenis. Micropenis.
Be number one. On the grounds of one of the most historic churches in Virginia, you're hearing a rendition of an ancient Georgian solo. It's a cherished song in Stephen Pruitt's favorite place.
It's very simple. It's only one word, which means many years.
His love of music and singing even inspired his Wikipedia username. Sir Montillo de Nicolau is his favorite.
All right, so there, yeah, a short. So my first short, hopefully there'll be more. I'll put it on my website, so it's some kind of more permanent feature, and I'd encourage people to download and repost wherever possible. I mean, there's all these other dopey websites, TikTok, whatever, I don't know. So maybe somebody can do that. And maybe somebody can make their own little commercial demonstrating Wikipedia to be the shithole that it is. Okay. And that's what it's demonstrating. I mean, I haven't heard from one single Wikipedia editor saying, gee, I'm really sorry about that. That's really unfortunate. They treated you so badly. So far, none of them are embarrassed by the conduct. They're all for it. So I will make a list of the screen names, the usernames, Sir Lancelot and whatnot, all their little usernames. But whatever. It's just so bad that this is what runs the world. All right, so we're going to continue this argument about the simple truth. This is Newton's mechanics. Newton, Galileo, Descartes, MV. This is the real thing. So it's all about mass, which is matter, and the force, which makes the matter move a velocity. And that's all you need to know. So everything that happens in the universe happens because a mass interacts with either a force or another mass that's carrying a force. So it's all about force interactions, but the only way the force can interact is it needs the conduit of the mass. The mass is the catalyst. So the force is out there doing all this stuff, but it can't interact with itself. And it's the catalyst of mass that gives it the capacity to create different outcomes. And this idiotic other theory with this silly squared velocity that makes no sense at all. I mean, a cube of velocity. What the hell is that? I can make a cube of velocity? No, I can't. So it doesn't make any sense. And this is just, made up bullshit here. The fact is this is all there is. And this squared thing, just a fable. Just a story they told hundreds of years ago, had no evidence for it. They fooled people in the 1700s with little show experiments that weren't scientific. I mean, they were pseudoscience. They were really childish even. You could call them childlessly flawed in the reasoning. Easy to debunk. Wouldn't pass a real physicist's scrutiny today. I mean, a real physicist couldn't honestly say, yeah, that's a good experiment. Couldn't be defended. Like the Eddington experiment, just really can't be honestly defended as good science. But here we are nonetheless. It's just very tragic that the world is just made out of shitty people promoting shitty ideas. And most of those are religious people, and frankly, that's what most of the scientists are. They're fabulists. They want a fake truth. They don't want the real truth. They want bullshit and lies. And it's all really, really sad. So I could go back a little further here where they're talking about energy. And they mentioned fossil fuels. And it's always an important thing to say about fossil fuels is fossil fuels aren't some kind of different kind of energy. It's just solar energy. It's just, billions of years of solar energy stored in that black goop. Days and days and days, months and months and months of solar energy in a little tiny vial. And that's why it has such energy potential, is because it's a really lot of energy. It's a lot of solar energy, a lot of hours of solar energy stored in the little black soup. Anyway. All right, while these two categories are sufficient to describe all forms of energy, so again, these two silly categories of active See, they say kinetic, and it's just a lie because, their kinetic is the stupid idiotic formula. They can't get that out of their head. So when they say energy, they don't mean momentum. They mean this specialized formula bullshit. So it just ruins vocabulary. And what we're really talking about is active forms of energy and ones that are hidden. So you could argue that the difference is between energy that's moving, that's free and going in a direction, and energy that's trapped in, say, a circle. And the energy's stuck somewhere and it's not going anywhere. It's vibrating back and forth or something. It's doing something that keeps it from being visible. So you could just argue visible versus invisible energy, but it's all the same thing. It's just pieces of matter moving or the force itself. That's it. Force pushing a piece of matter or force moving the speed of light. That's all there is. That's all there's evidence that there is. All right. It is often convenient to refer to a particular combination of potential and kinetic energy as its own form. So I don't even know what that means. So again, this is another duality or something. It's potential. It's actively trapped. It's trapal. What kind of word barf are we going to turn it into to make that pile of crap mean anything? Clearly, the energy is either discrete, small, hidden, or the energy is obvious, elephant coming at you backwards with its big giant butt. For example, the sum of transitional and rotational kinetic energy. So again, just because something can be rotating, that's part of its energy. So the wheels in your car are actually storing some of your momentum. Some of your momentum is in the form of the rotating tire. And potential energy within a system is referred to as mechanical energy. So, why even bother with this, right? This is all so silly. All of it is mechanical. There's no such thing as a non-mechanical piece of energy. All of it is matter moving. All right, let's see what this says. In physical sciences, so again, they're telling us what the science says. This is 100 people writing this crap. That's it. So 100 people are going to tell us what we have to believe and how we're going to use our vocabulary. Is the sum of potential energy and kinetic energy. So baby talk. The principle of conservation of mechanical energy states that if an isolated system is subject only to conservative forces, then the mechanical energy, I guess is going to say, is conserved. Obviously, if there's so much motion in a system, you can't make more motion in the system. Okay? The motion is just transferred from one object to another object to another object to another object. The energy is indestructible. It moves forever. The force is indestructible. And all you're saying is that some of the force is still going the speed of light in the universe. It's free. And some of the force is pushing electrons and protons. That's it. That's the only distinction necessary. Some force is pushing matter. Some force is free. Period. Done. Really simple. Physics is really simple. All right. Whereas nuclear energy refers to combined potentials within an atomic nucleus. So there's no potential. The atomic nucleus is made inside of a pressurized vessel, inside a sun. And the pieces are smushed together really close, but there's a whole bunch of springs compressed when they're forced into that configuration. And so it's like they put a bunch of magnets together in just the right configuration where they made the magnets really close to each other. But if I just change something a little bit, the magnets will spring apart. Okay, so that's the idea. Not that complicated. All right. A nucleus in either the nuclear force or the weak force. So there's no nuclear force. There's no, that I think they mean the strong force when they say nuclear force, right? The nuclear force is a force that acts between hadrons, most commonly observed between protons and neutrons of atoms. Obviously, there's no force pushing those things together because they're compatible things. They like each other. You don't need a strong force because they like each other. Okay, so just more garbage. So then, instead of just saying strong force and weak force, then they say nuclear force instead of the, so they're pretending there's another force called the nuclear force. So they say there's 4 forces, and now they're going to say there's 5 forces. Again, vocabulary doesn't matter to these people. They just couldn't care less that words would be consistently used. Okay, some forms of energy that an object or system can have as a measurable property. So they're calling these forms of energy, but they're all the same thing. It's either a force moving the speed of light, or it's a force moving slower than the speed of light because it's pushing a piece of matter, an electron or a proton, and the atoms that the electrons and protons would be made out of. All right, so they say mechanical, the sum of microscopic, transitional, and rotational kinetic and potential energies. So just a bunch of wooey mush. You can't make any sense out of it at all. It's just motions. All of it's just motion. Circular, back and forth, or moving away. Potential energy due to or stored in electric fields. So they're calling a special kind of energy is electric. The energy of electric is always active. That is, for there to be electricity, you have to have current moving, voltage moving. That's electricity. So obviously, there's no stored thing called electricity. Okay, you're storing something else in a battery. It's not electricity until you release it. Okay, when it's in the battery, it's some sort of chemistry. That is, it's the pressure of the atoms, the size of the atoms. You have ions or you have something else, and you're going to convert those ions into something else, and then you're going to have electricity. But you don't have electricity when it's just an ion. All right, magnetic. Potential energy due to stored in magnetic field. So again, more nonsense. A magnet is not producing anything. A magnet is merely reflecting the universe that hits it differently. So it's the same energy coming off a magnet that comes off a non-magnetized steel. I have a magnetic piece of steel. I have a non-magnetic piece of steel. Exactly the same energy is reflecting off the two pieces of steel. The magnet doesn't absorb more energy. The steel doesn't absorb more energy. Exactly the same thing is reflecting, and all they've done is change the reflection. The magnet changes what the reflection looks like. So instead of the reflection looking like this, the reflection looks like this. And something else that can see this, some other dipole that can see the change in the pattern, that will react to the magnet because it can see it. It hits it differently. It's a pattern. That's all it is. There's no extra energy. All right, gravitational is the big one. Potential energy due to or stored in gravitational fields. So again, the gravitational field is a consequence of the fact that you're moving matter. When the force moves matter, the force is less energetic. Because the force can't go as fast when it's pushing matter, it loses a little bit of velocity in a sense. So a little bit of its capacity to move stuff in the universe is diminished because it's essentially being delayed pushing the matter. That's the force differential. That's what causes gravity. All right, chemical. Potential energy due to chemical bonds. So that's, again, just atomic. So you're just saying basically about adding or subtracting electrons. And that's all it's really about. You're adding pressure when you add electrons. You're subtracting pressure when you remove the electrons. Ionization is exactly the same damn thing as the chemical. Potential energy in bonds an electron to its atoms or molecules. Now, a lot of electrons don't have an atom. They're just floating around saying, I see that atom over there and I would like to be associated with it. But that's all it is associated. So there's a ton of atoms on you right now, electrons on you right now that aren't atomically connected. They're just associated with you because you have a bunch of positive nuclei inside of you and they can see them. Okay, potential energy, okay, nuclear, that binds nucleons to form the atomic nucleus. So yes, and the bond is really between electrons and protons. So the nuclear energy is in the form of electrons and protons being arranged very compactly. And in that compactness is stored a bunch of pressure. Okay, that's the counter pressure of the attraction of the electrons to the protons and the opposite pressure of the repulsion of the electrons from each other and the repulsion of the protons. So again, if I had a proton here and a proton here and I stuck an electron between them, you can understand they get very close together. But as soon as I put the two protons where they can see each other, where they're not being blocked by the electron anymore, you can understand that they have tremendous pressure pushing them apart. They have lots of energy they'll push on each other with. All right. So chromodynamic. So this is a bunch of quantum mechanical bullshit, this chromodynamic crap. There's no chromodynamic anything. This is all just complete fable. So it's potential energy that binds quarks to form hadrons. So just absolute nonsense. Won't even bother. Just made up fable. You might as well just say gremlin dynamic, gremlo dynamic, gremlo dynamic, pixie dynamic, Sasquatch dynamic. All right, just absolute made up shit. All right. So elastic, silly kind of nothing word. Potential energy due to the deformation of a material. Clearly not the deformation of the material or its container. No. Steel is very elastic, doesn't do any deforming, doesn't do any restoring. Okay, what it does is reflecting, exhibiting a restorative force as it returns to its original shape. Piece of steel is not doing that. It's just saying, fuck you, I don't want what you got. Okay, and it just says, bounce. Bounce all you want. Okay, I'm not interested in playing. Completely inelastic. The harder you make the steel, the less you make it move, the more it reflects. Fact. All right, mechanical wave, baby talk. So just absolute baby talk, mechanical wave, baby talk. Kinetic and potential energy in an elastic material due to propagating oscillation of matter. So there's just moving matter. So again, yes, you're going up and down, up and down, up. Yes, you're oscillating. That oscillation is a form of energy, obviously, and it's caused because obviously the mechanism is either you're pulling electrons apart from protons and they want to get back to where they were, so that's the elastic of the oscillator, or you can have much more complicated oscillators, much more mechanical, where you have a piece of steel and a piece of steel and a ball bearing bounces back and forth between the two steel, because it's a reflection. All right, same thing with light. You can create a laser beam because you can reflect light. Kinetic and potential energy. So this is sound. So sound is just movement of the atmospheric atoms. Not interesting. Radiant, obviously, okay. Lots of forms of energy in the form of radiation, and all of them are moving the speed of light. So the key ingredient is that's free energy. That's the energy that is free. It's not pushing any matter. So the photons, all the stuff they call electromagnetic, all that radiation is free. It's not moving matter. Okay, it's moving the speed of light, just like the gravity. Okay, the speed of force. All right, potential energy due to an object's rest mass. Well, I might as well just say, okay, that's pixie dust. Doesn't have anything to do with anything real. And then they say thermal. Okay, so this heat thing is, again, just like the sound thing pretty much. It's just the movement. Okay, you're just talking about I'm going to vibrate. Either I'm going to vibrate electrons or I'm going to vibrate whole atoms. But it's just vibrations. So they call it kinetic energy of microscopic motion of particles. Duh. I mean, so could it be any more vague? That's exactly what sound is doing. It's moving little atoms. It's vibrating atoms. It's pushing and moving atoms. Same difference. So heat is really sound. It's just another form of heat. Okay, a kind of disordered equivalent of mechanical energy. It's not kind of disordered. It's very ordered. And it is just mechanical energy. You're just saying, I'm going to force the force to move stuff. If the force is moving stuff going that way, then I can't use the force going over here somewhere because it's going that way, obviously. So heat is watching force go in a direction. So if heat's going in a direction, well, that means the force went in that way, and you're losing it. And it's going to go somewhere, and eventually it's going to become invisible again. It's going to go back to being radiation, and you're not going to be able to see it. All right, so now the history. This ought to be very, very funny. Because this will be just where it's all made up. Okay, and so they say main articles. Okay, history of energy. So I guess we got a main article to go to. So that ought to be funny too. And then we have the timeline of thermodynamics, which I don't know what the fuck that is. Statistical mechanics. That's got to be rubbish. And random processes. So obviously, there's no such thing as a random process. The entire universe is cause and effect, and things only are synthetically random. There is no real random. Okay. The word energy derives from the ancient Greek. Who cares? Okay. Activity operation. So that's fine. Who cares? But good. Which possibly appears for the first time in the work of Aristotle. The word energy did? Wow, that's amazing that nobody caught on and used it again for thousands of years. In the 4th century, well, I guess it's not thousands, it's 1,500 years. In contrast to the modern definition, ENerGY was a qualitative philosophical concept broad enough to include areas such as happiness and pleasure. Well, then we really know, okay. But look, we still do that, right? We call somebody he has an energetic personality, or they say some kind of bullshit like that. So we've still polluted the word a little bit. But it's unfortunate that, yes, they lost this very nice word, and then we're stuck with quantity of motion for, most of the centuries of real work on the subject. There's Leibniz's name, the magic piece of turd. Okay, in the late 17th century, so we're talking about 1783 or 4 or 6. I guess it's 80. It's the same year Newton published the Principia, and 8 months or so before Newton, or even 4 months, Leibniz published the first time saying this silly crap. This absolute crap that nobody believed because it's silly. Okay. Gottfried Leibniz. He wanted to be called von Leibniz, by the way. So you're sort of insulting him a little bit because you're not calling him von Leibniz. That was his preference, was to be called von Leibniz. Even though he wasn't a von, he preferred to be referred to as Wilhelm Gottfried von Leibniz. Proposed the idea of the Latin vis viva. Yeah, everything was proposed in Latin, unfortunately. Unfortunately, these fucktards, and frankly, I don't know why the fuck Newton, an Englishman, would publish in Latin. I really don't understand it. It doesn't make any sense to me. It's just ridiculous, frankly. Why wouldn't... English is such a good language. It's so rich and so deep. You can make up words so easily. It's so adverbish and adjectivish, and it has so much to it. Why wouldn't you use it? Anyway, vis visa, or living force. So look, it wasn't entirely stupid for them to talk about living force and dead force, the idea of potential versus active. So yeah, you had energy you could see, and then you had energy that you couldn't see, okay, like heat. You can't see it. You have to touch something to feel it. So there was lots of reason to have some idea of something that's active and something that's dead or inactive. So it's not terrible. But obviously, in Leibniz's mind, living force was more like soul force. It was a religious concept, that this was the kind of force that from God, it was God's energy in things. It was the manufacture of your soul. It really wasn't physics, and it wasn't science. It was a religious concept for this guy, which defined as the product of the mass of an object and its velocity squared, which is just silly. A squared velocity is a silly concept. There's no such thing as an area or a volume of velocity. He believed that the total vis visa was conserved, and he believed it, and he had no evidence. So all he ever said was, as evidence, he said 4 pounds dropped 1 foot is the same energy as 1 pound dropped 4 feet. That's it. That's all he had, was his axiom. And some people fell for it. I mean, they said, oh yeah, that's right, because they didn't think about it. But it's not right. It's not the truth. It isn't true. And all of physics has been fatally corrupted by this idiotic, bad, fabulistic, religious concept. All right, anyway. To account for slowing due to friction, Leibniz theorized that thermal energy consisted of motions of the constituent parts of matter. They all did. So no, this wasn't Leibniz didn't figure out what friction was, okay? They all theorized about how objects lost energy. So even when they did experiments in this, later where they, I think Newton did some of these, where clay, you use clay and the clay smashes together and you see that the clay deforms. I mean, Newton's obviously saying, well, yeah, the energy doesn't stay in the object because it's made the little pieces move. And so you can make little pieces move, and that requires you to use the energy that you had. So the force, the energy that the object had when it was moving linear motion, the linear motion was converted into a bunch of motions in all kinds of directions. So again, this isn't Leibniz's idea. All of them believe this. I mean, I hate when they do this, when they sit there and say somebody invented an idea that isn't even close. They didn't invent it. Even the idea of the R squared thing. I mean, obviously, Newton in his own book does cite the other people that had referenced it. I mean, it's not like he is saying, I'm the only one who ever thought of the idea. He'll certainly say he thought of it first, but he's not going to sit there and argue he was the only person. Come on. All right, anyway. He believed that vis visa was conserved. To account for the slowing due to friction, Leibniz theorized that thermal energy consisted of motion of the constituent parts of the matter, although it would be more than a century until this was generally accepted. So I think that's just not a fact of the actual history. I think Newton already accepted it. I think Galileo already accepted it. So I think that, and Descartes. I think it's absolute nonsense to suggest they hadn't already figured out that the energy can move little tiny things inside the objects. So it's just a nonsense. So that's just that sentence is absolute crap. So I don't know where they got a footnote for that piece of shit, because that's a piece of shit. All right, the modern analog of this property, kinetic energy. All right, so they're conceding when they say the word kinetic energy, they're talking about mv squared. Now they didn't put Leibniz didn't put the half in front of it, so obviously his actual quantitative answers were way off because they were twice as much energy as it should have been actual. All right, differs from vis visa only by a factor of 2. Only? Yeah, it only differs by a factor of 2. The elephant's only twice as heavy. Twice as heavy isn't very heavy, is it? Oh, amazing. Writing in the early 18th century, Émile de Chartelet. So this is the woman who did the little fake clay experiments, okay? Totally exaggerated her import. She really didn't do shit good science. She just took other people's experiments and showed them off. She had money, so she published. And that's it. There's nothing great about this story. Yes, she was an accomplished woman, no doubt about it. But this is fake news, frankly. All right, she's not the great thinker of the 1700s. All right, writing the early 18th century. So we're talking about 1730 to 1740 was her active period. She died very young, 40 years old, having a stupid fucking retarded baby. Anyway, a illegitimate baby All right, proposed the concept of conservation of energy. So again, this is just not the truth, okay? All of them believed in this. Descartes basically diagrammed the universe as being all this stuff is already in it. The universe has already got all of its stuff in it, and you're just watching it change shape. All the energy goes in circles. That's Descartes, 200 years before her. So why are they saying this? This is just such crap. This is fake science. She did not invent the concept. All right. In physics and chemistry, the law of conservation of energy states that the total energy of an isolated system remains constant. So if they mean conservation of mv squared, well, of course, Descartes, Newton, and Galileo didn't believe in that shit, but they certainly believed in conservation of momentum. Undeniable. They understood conservation of momentum. I mean, this is just such crap physics. This is crap history. All right. It is said to be conserved over time. What does that even mean? It's conserved, period. There's no unconserved moments. So why would I even say over time? There's no millisecond where the universe is absent its energy. In the case of a closed system, the principle says that the total amount of energy within, no doubt it says something like always remains the same. And again, all of them knew, oh God, I just hate this shit. It always does this crap. So I have to go find where I was again? Oh, damn it. Damn it. Alright, pause. Alright, seems I'm back. Anyway, I can't, my mouse is I have to click it now and then or it doesn't stay working. Whatever. Alright, so the Chardonnay proposed the concepts of conservation of energy. So that's a lie. In the Marguerite blah 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 of her French language translation of Newton's Principia Mathematica. So this is what she was working on right up to the day she died. She was still working on this translation of Newton's Principia. And there's some speculation that she had already converted, back to being a Newtonian at this time. So there is some indication in the letters of Voltaire that she had all reclamated her intelligence and realized that the Leibnizian crap was crap. Now let's understand, she was tutored by, she didn't ever went to college, she was tutored by a Leibnizian, right? So one of the few people on earth who were Leibnizians, and he actually sued her for plagiarism. So she was just spouting what the teacher had told her. And so it was so much word for word what he had taught her that he actually sued her for plagiarism when she published. So this wasn't any original thought on her part. All right, so she was obviously just a gullible, she was gullible. Which represented the first formulation of conserved measurable quantity that was distinct from momentum. So there we go. So all they're saying is that the concept of conservation of the fable, the fake energy, conservation of fake energy was her proposal. Not conservation of energy, it was as it was known by everyone else. So at this period, 1720s, 1730, everybody still believed in Newton. All right, everybody still believed in momentum. And then she did these silly clay experiments. Now, they're not going to detail the silly clay experiments here. Okay, and they fooled people. And that's it. They just fooled the gullible, the stupid, the ignorant. All right, but they were bullshit experiments, bad science. They were essentially pseudoscience as presented. Okay, which would later be called energy. Okay, right, so that's all they're really saying. She proposed conservation of fake energy. Okay, conservation of mv squared, conservation of living force. Now I think Leibniz would have probably said you have to conserve the living force. So again, the whole argument that she has something to do with inventing the idea of conservation of energy is just nonsense. It's just fake history. All right, in 1807, well, maybe I'll take a break here and decide how far I want to go in this video and such. All right, back. All right, so let's start with the Thomas Young story. So it should be understood, Thomas Young, great guy. I mean, medical doctor, did tons of stuff, working with light, color blindness, all kinds of different things, music, sound, lots of great experiments, lots of great insights, lots of great science. But some of it is just crap, and his whole crappy double slit crap was crap. Okay, and this crap, okay, about energy was crap. Now his purpose in making this crap was very admirable. Okay, so Thomas Young is cited as the guy who invented the term energy, the first person to use it. And he used it for the first time because he wanted women to be more interested in science. So he wanted to do he did some science lectures for women. All right, so he, took out some of the technical rhetoric, made it simpler to understand, and that's the reason why I use this term energy to describe this whole category of stuff moving around and doing stuff, force and energy. So that's how the word was first used, was in lectures intended for kind of a, catch-up audience, an audience that needs to be, elevated to being capable of understanding the vocabulary and the concepts. And so it was sort of a baby word for quantity of motion and living force and all of that crap. Okay, so in 1807, Thomas Young was possibly the first to use the term energy instead of vis visa. So obviously vis visa, doing Latin shit, wouldn't work in a lecture for dummies. I'm not insulting women, I'm just saying he was doing a lecture for dummies is what he was doing. And obviously a lecture for dummies doesn't need a bunch of Latin terms thrown in it. Okay, energy instead of vis visa in its modern sense. Okay. And then this Cornelius guy described kinetic energy in 1829 in its modern sense, and in 1853. So we're talking about a huge jump here, right? From 1807 to 1853, and they still hadn't nailed all this down. So what guy was responsible for the work equation, which became the circular crap? That was the way you made this whole thing circular. That's how you put the half in front of the damn living force. Because it really gets wrong answers until you put that half in front of it. Well, it still gets wrong answers, don't get me wrong. So this is another tragic story. This guy, died being used up on a stupid island. He died of cholera. I mean, just a waste of another smart guy. Anyway, okay, and so... and in 53, William Röntgen, and I don't remember him having anything to do with this, Scottish mathematician and physicist. He was the founding contributor with Rudolf Coleridge and William Thomson to the science of thermodynamics. So again, this is just where they invented the circular math. Okay, so this is where they did the force times distance equals work. That nonsense. All right, so the law of conservation of energy was also postulated in the early 19th century. So why would they even talk about it being postulated in the 19th century when you say she already invented it in the 1700s? And we already know that Galileo, Descartes, and Newton already said it. I mean, it's too stupid, and applies to any isolated system. So more nonsense about an isolated system, whatever the fuck that would be. It was argued for some years whether heat was a physical substance. Yet the idea was, though, that they all figured out that the heat was using up the energy. It was, taking something's mojo. That to make heat, you had to use up something's momentum, okay? You couldn't make heat without using momentum. You had to rub the sticks together. You had to do something. You had to move stuff and cause it not to go anywhere to make heat. All right. Dubbed the caloric, are merely a physical quantity. So heat was just like electricity. It was like this subtle thing that they knew took place, right? It's this little invisible stuff, this little, but they really did understand that the movement of a big thing created the movement of the little things. They were already getting the whole idea of atoms, the idea that there's little pieces inside of substances, and what you're really doing is like, they had glass, glass back then. They could put sand in the glass, and then they could flick the glass with their finger and see the sand molecules move, the corpuscles of sand, and they could get the idea. So it wasn't like this was foreign to them, and this was some magical insight that was going to be provided, that they didn't understand the concept. This is like, you don't need Moses to bring down a written on a rock that says, thou shalt not murder. Oh, duh. I couldn't figure that out on my own. All right. Such as momentum. Okay, so merely a physical quantity such as momentum. So this is where they're turning, where they're graying the lines and making this all into fudge. Okay, we know momentum works. We know it has every bit of validity. It doesn't fail you anywhere. You won't go wrong thinking in terms of momentum, the momentum of the elephant's ass coming for you. That will give you a very good indication of what's going to take place. In 1845, James Prescott Joule discovered, now he didn't do this, so this will be another lie, okay? So Joule was a brewer, okay? So he really wasn't a scientist in the strict sense of the word, but he did lots and lots of experiments, and he was really just trying to find out a way to measure absolute energy. That is, to take anything that's moving and convert it into this simple heat substance, okay, and then measure how much total energy it actually had, because its heat will represent what it had. And that's a very good theory, very good work he did, but frankly, again, trivial analysis of the experiments recognizes that, he's not free fall dropping things in gravity, and you can't make the same calculation. When you drop something slowly in gravity because you're applying friction or you're applying a weight, that you're collecting more gravity, that it isn't the same amount of gravity. If you allow something to fall slowly, it will actually contain more energy total, because it's in the gravity a longer amount of time, and whatever you're doing to slow it down is where you're going to collect that extra energy. And that misunderstanding is the whole reason why the joule exists. Anyway, discovered the link between mechanical work and the generation of heat. So it was a huge, yes, that was really brilliant. He wanted, and he didn't do it for scientific reasons. He did it because, he had to deal with an economy, and he had to decide whether to use a steam engine or to use the new electrical engine to run his mills. And so that was the real question. Which one's more efficient, steam power or electric power? And he wanted to know which one was more efficient, and there was no way to know that because no one had done any, empirical testing to figure out which one is more efficient. So that's what he was after, and he did a lot of good science trying to get the answer. All right, these developments led to the theory of conservation of energy. So this sentence is just such a lie. I mean, come on. They all believed in the idea of conservation of energy. Leibniz, Newton, Descartes, Galileo, all back then. You don't need to wait 200 years to start talking about conservation. It's just nonsense. Formalized largely by William Thomson, Lord Kelvin. So just more nonsense. Not formalized in any way. It's all a nonsense formula. Work equals F times distance, when it should be F times time. It's just a breaking of all that Newton, gave them, and they threw it all away to live in the fantasy of this fake kinetic energy, scalar magic, free energy. Lord Kelvin as a field of thermodynamics. Thermodynamics added the rapid development of the explanations of chemical processes by Rudolph, some other guy again, Josiah Willard Gibbs, and Weather Nernst. I've seen him before. Known for his work in thermodynamics, physical chemistry, electrochemistry, and solid-state physics. His formulation of the Nernst heat theorem. So again, all of this stuff is probably legitimate, but it doesn't need you to believe in 1/2 mv squared. So all of this stuff doesn't have anything to do with 1/2 mv squared. All right. It also led to the mathematical formulation of the concept of entropy by Claudius and an introduction of the laws of radiant energy by Stefan. So look, I'm still going to tell you all of this crap just comes down to the bottom line that you cannot destroy matter or force. So the universe has matter, electrons and protons, can't make them go away, can't make new ones, and it has force, and you can't make any of it, you can't make it disappear. And that's all that's happening. The force is pushing the matter bits around, period. All right, and it's pushing them into clumps. The universe is clumping because of that process. All right. The conservation of energy is a consequence of the fact that the laws of physics do not change over time. So again, the law is that the force goes the speed of light when it's not pushing matter, and when it's pushing matter, it's going to go some slower speed because it's pushing a piece of heavy matter. Thus, since 1918, theorists have understood that the law of conservation of energy, so the idea is it's not really conserved, right? So the more you're moving matter, the less force is in the universe. And the less matter is being moved, the more force there is free in the universe. So you can sort of understand that matter moving automatically reduces the amount of force in the universe because it's slowing the force down. All right. Is the direct mathematical consequence of transitional symmetry of the quantitative conjugate to energy, namely time. So more nonsense. But obviously time is insanely important, and they just don't pay any attention to it. Everything is decided. Force times time, not force times distance. Time, how long it takes you to lift something will decide how much work you will do. Okay? Not how far you lift it. How much time you take to lift it will decide how much work you're going to do against the gravity. All right, that's probably a good enough place to stop. Units of measure, that ought to be pretty boring, so we might skip that part. The SI units. Yeah, we will start off with classical mechanics. That'll be much more interesting. Because, yeah, the unit part is just going to be boring. All right, so I think that's what we'll do. So that'll be next time when we come back to this subject. So this is the edition 2 on energy, I believe, or yeah, 2. Okay. So it's on the website. So links to these videos will be on the website in the order in which they were produced and such. So till the next time, Wikipedia is garbage science. Okay, it's science written by 15 people, edited by fucktards, and that's tragic. Really tragic.
On the grounds of one of the most historic churches in
churches.
Virginia, you're hearing
Not a good place to do
ancient
science.
Georgian solo. It's a cherished song.